This video is a preview of the MathGalaxy pre-algebra fun tutorial, and here we're going to be reviewing powers and exponents. Powers, also called exponents, are a shorthand way of writing repeated multiplication of a number. For example, the 3 above means that 2 is multiplied 3 times. So instead of writing 2 times 2 times 2, the shorthand, and that's all it is, a shorthand, is 2 to the 3rd power. The 2 is called the base, and the 3 is called the power or the exponent. And when you multiply powers of the same base, you add the exponents. So 2 to the 3rd means 2 times 2 times 2 times 4 more 2's, so a total of 7 2's. So if they're on the same line, the shortcut rule is that you add the exponents. And you can only combine exponents of like bases. So here, this is 2 to the 3rd, and you have 2 8s, so it's 8 squared. So here, you can't combine the 2 and the 8, but you combine these 3 2's with these 2 2's for a total of 5 2's. And 2 8's times 2 more 8's is a total of 4 8's multiplied together in the shorthand. If there's no exponent, it's understood to be 1. So if the power is 1, you won't see it written, it's understood. So 2 5's times a 3rd 5 is 3 5's multiplied together. And with division, the like numbers cancel out. So you have 5 2's on top, 3 2's on the bottom. So those 2 2's cancel out, those cancel out, those cancel out, leaving 2 2's on top. The shorthand rule for division is subtraction. 5 minus 3 is 2. But that's just a shortcut. You should remember that it's based upon this basic idea. 3 2's here canceling out 3 on top. And so, again, this is another way of writing 5 2's canceled out by 3 2's leaves 2 2's. And if there are more 2's in the denominator, well, when you cancel these 2's out, it's like dividing top and bottom by 2. Remember, when you divide, there's always a 1 left. So you have a 1 left here, 1 left there. Same with those 2 and those 2's. So what you're left is 1 times 1 times 1 on top, and 1 times 1 times 1 times 2 times 2 on the bottom. And another shorthand that people have developed is that a power in the denominator can be represented on one line as a negative power. So that's just by definition. A negative power means it's in the denominator. And of course, there's a 1 in the numerator. So probably because this takes 3 lines to write in an equation or in a book, someone wanted a way to write it on 1 line. So that's all that it is. It's a shorthand. But the subtraction rule still works. 3 minus 5 is a negative 2. And for exponents and bases on the same line, the addition rule still applies. 5 plus a negative 3 is a 2. Because these 3's by definition are in the denominator, so they're canceling out 3 of the 5. But as always, if you're not sure what the shorthand notation means, goes back to the basic definitions. Any number to the 0th power is 1. That's to keep the system consistent. For example, 2 to the 3rd divided by 2 to the 3rd is 1. By the subtraction rule, it's 2 to the 3 minus 3, or 2 to the 0. Same, number divided by itself is equal to 1. By the subtraction rule, it's x to the 3 minus 3, or x to the 0. So x to the 0 is equal to 1. anything to the 0th power is equal to 1. Okay, so here the negative power means that it's in the denominator. What if you have a negative power in the denominator? Well, you can represent this as 1 over 2 cubed in the denominator. So you have a complex fraction where the denominator itself is a fraction. And how do you get rid of that? Well, you multiply top and bottom by the overall fraction in a way that gets rid of the denominator. So you could think of this as was 2 cubed over 1. So a number times its inverse is equal to 1. In this subproblem, those cancel out. So you end up with 2 cubed on top, 1 in the denominator. And the shortcut rule to remember is that when a power crosses the division line, it changes sign. So when this goes to the denominator, it becomes positive. When this goes up to the numerator, it becomes positive. But that's just a shorthand way of remembering it. It's all based upon legitimate operations. And another way to think of converting this is multiplying top and bottom by 2 cubed. This gives us 2 cubed on top. By the addition rule, 2 to the minus 3 plus 3 is 2 to the 0, which is equal to 1. Okay, the next rule is a power to a power. And the shortcut rule is multiplication. 3 times 5 is 15. But it goes back to the basic definition. This 5 is saying what's inside the parentheses is repeated 5 times. So you have 2 cubed times 2 cubed times 2 cubed times 2 cubed times 2 cubed. And by the addition rule, it's 3 2's repeated 5 times, or 2 to the 15th. And it still applies with negative powers. Negative 3 times 5 is negative 15, because this is 1 over 2 cubed repeated 5 times, or 2 to the 15th in the denominator, which is equivalent to that. And again, going back to the basic definition, this is repeated 3 times, so it's 2 squared over 5 cubed 3 times. So everything is raised to the power. So 3 times 2 is 6, 2 to the 6th, because you have 2 2's repeated 3 times. And you have 3 5's in the denominator, that's repeated 3 times, so it's 3 times 3, or 9. And the powers rule also applies to variables. So b times b is b squared, x times x is x cubed. But the rules only apply to multiplication and division. So if there's addition and subtraction, you can't combine them. There still has to be 2 cubed plus 2 squared, x cubed plus x squared. Now let's look at operations with powers. So let's say if you have this times this. So 5 times 4 gives you 20. 5x's and negative 2x's. So these are like 2x's in the denominator, canceling out 2 on top. So by the addition rule, for bases on the same line, you add them. 5 plus the negative 2 is 3. We have 2 y's here times 3 more y's, so a total of 5 y's. You have 1 z in the denominator times 2 z's in the denominator. Or by the addition rule, minus 1 plus a minus 2 is a minus 3, which represents the 3 z's in the denominator. And we're not going to analyze this in detail. You can pause the screen if you want to look at it and analyze it some more. Okay, so here, if we combine in the numerator, 5 times 6 is 30. 2b's times 3b's is 5b's. 2 c's in the denominator times 1 in the numerator is, this cancels out 1 in the denominator, leaving 1 in the denominator. Or by addition rule, minus 2 plus 1 is minus 1. And this stays the same. So 30 divided by 2 is 15. By the subtraction rule for division, the b's are 5 minus a minus 3. And a minus is a plus, so that gives you 5 plus 3 or 8 b's. And for C, it's minus 1, minus 4, or minus 5. And again, you can pause the screen if you want to analyze this in more detail. Okay, so here, one place you have to be careful is that this is not 3 times 7, because this is 7 to the first. So the power is 3 times 1, or 3, because what's inside the parentheses is repeated 3 times. So you have the 7 repeated 3 times. So that's where you have to be very careful with numbers. The rest of it is power to a power. 3 times minus 4 is minus 12. 3 times 2 is 6. Okay, so again, here, power to a power. So 2 to the first, so 1 times minus 3 is 2 to the minus 3. And minus 2 times minus 3 is a positive 6. And again, you can pause the screen to analyze this in more detail. But remember, these rules do not apply to addition or subtraction. So that's the end of our review of exponents, powers, and operations with them. This has been a preview of the MathGalaxy pre-algebra fun tutorial where we looked at the powers, exponents, and operations with powers topics. You can find more details and practice in the tutorial. Thank you for listening.